Hey everyone, this video is for Unit 3 on factoring. We're in Lesson 3, Factoring Trinomials, when the coefficient in front of x squared is greater than 1. So in the last lesson, x squared always had a number 1 in front of it. So in this lesson, we have more. So you should get your note pack out. These are the examples in your note pack. So number 1 is 3x squared plus 8x plus 5. So the first rule of factoring is to make sure there's not a GCF in the problem. So if I look at 3, 8, and 5, there's no number that goes into both 3, 8, and into 5. There's not an x that will come out of it either, since this has an x squared, this is an x, and this has nothing. So nothing can pull out of that. So as mentioned in previous lessons, if I have a 2 here, it will factor into 2 binomials if it's factorable. So how would I get a 3x squared? Well, to get a 3x squared, I would have to have a 3x and an x. And I get the question all the time, does it matter where you place them? No, it doesn't, because 3x times x would be the same thing as x times 3x. You're going to get the same thing there. So that works for the first piece. To get a 5, that piece, the positive 5, would have to go here and here. So to get a 5, I only have one option, 1 times 5. So some people ask me, it doesn't matter if I put a 1 here or 5 here. Well, it actually does in these problems because of how the outer and the inner terms work, and I'll show you that in just a second. So let's put a 1 here and a 5 here to begin with. So now think about this. This is a positive 5. So to get a positive 5, either both of these have to be positive or both of them have to be negative. So I could have 3x minus 1, excuse me, and then x, excuse me again. So they can both be minuses or they can both be positives. Because either way, like 3x times x would be 3x squared. Because remember, I checked my first terms, and 1 times 5 would be 5, positive 5. 3x times 3x, or 3x times x would be 3x squared, and negative 1 times negative 5 would be positive 5. So either way, the first and last terms work. So now we have to make the inner term work. So all I did here was change the signs. So you should know from previous videos what that does. So 3x times 5 would give you positive 15x, and 1 times x would give me positive x. So that would be 16x in the middle, and what I need is 8x. So that doesn't work. So since I kept my numbers over here and just changed my signs, we should know that this is going to give me negative 15x and minus x. That's only going to change the sign of the number. So this combination doesn't work because it doesn't give me positive 8. So what could I do? Well, in the last videos, in the last lesson, I had multiple things that I could put here. So if this was a 6, I could put a 1 or a 6 or a 2 or a 3. Well, since this is a 5, only 1 and 5 work. But notice this 3x times 5 is making this quantity 3 times as large. And this one is only getting multiplied by a 1x here. So whatever number's here is getting 3 times as large. So what could I do there? I could actually switch the order that I wrote the numbers. So what I mean by that is I could still have a 3x. I still have to have a 3x and an x. The signs still have to be the same. So they still both have to be positive or both negative. But I could put a 5 here and a 1 here. Because if I look at that, that's going to give me 3x squared in the front. And if I put 2 positives here, I would get positive 5 at the end, which works. So now check your outer and inner. 3x times 1 would be 3x. And then 5 times x would be 5x. So the middle term here is going to be 8x, positive 8x. In the problem, I need a positive 8x. So the middle term works. than the first and the last term works. So this would actually be my answer. 3x plus 5, parentheses, x plus 1. That would be my factored answer. Okay, so let's go to the second one. The second one says 5x squared minus 38x plus 21. So to get 5x squared, the first thing I need to do is check for GCFs. There's not a number that goes into both 5, 38, and 21. And I can't pull an x out, so there's no GCF to pull. And the x squared is positive, so I'm good to go there. So how would I get a 5x squared? The only way to do that is with a 5x and an x. Now I have to get a positive 21 here. So the numbers to give me 21 would be 1 and 21 and 3 and 2. Or 3 and 7, excuse me. So think about this. I would have 5x and x. I could either have both pluses or both minuses because I need to get a positive 21 here. So if you look at these numbers and try to process it in your head, then most of the time you can see which ones you need to pick. If I put 1 and 21 there, well, 5x times x will give me this, and 1 times 21 will give me this. But think about this. 5 times 21 would be a very big number. It's going to be 105x, and that would be x. 106 is much larger than 38, which is not what I need. So that's not going to work. If I put 1 and 21 over here and just change the signs, I'm going to get a negative 106. So that one doesn't work. So what if I change my 21 here and my 1 here? What does that do for me? Well, that's 5x times 1 would be 5x, and 21 times x would be 21x. That's 26x. Is not what I need. If I switch the signs, all that's going to do is give me negative 26x, so that's not the right one. So once you do a few of these, you may see quicker that I should try 3 and 7, because if I put 3 here and 7 here, the 7 gets multiplied by the 5, so that means it's 5 times as big. And then the 3 and the x. So 5 times bigger than 7 would be 35x, and 3 times x would be, sorry about that, plus 3x. So that would give me, and of course this works, 5x times x would give me 5x squared. 3 times positive 7 would be positive 21. So my first and last terms work. This gives me 38x, which is close, but it's the wrong sign. So all I have to do is change these signs. So if I put negative 3 and negative 7, same process. 5x times x would give me 5x squared. Negative 3 times negative 7 would be a positive 21 at the end. 5x times a negative 7 would be negative 35x. And negative 3 times x would be negative 3x. So that would give me negative 38x, which is exactly what I need. So that would be my answer. Go to the next one. First thing you have to do is see if a GCF will pull out. 3, 14, and 5, there's no number that goes into all three of those. And there's no variable that I could pull out. So this is going to break down into 2 parentheses since I have a squared here. So how do I get a 3x squared? 3x times an x. How would I get a negative 5? I would have to have a combination of 1 and 5. And to get a negative 5, I either have to have negative 1 times a 5, or I could have positive 1 times a negative 5. Either one of those would work. So what that means in the problem is I could have a plus here and a minus here, or a minus here and a plus here. It doesn't matter. You're just going to have to guess and check to see what works. So the only combination would be 5 and 1. Whatever's in this gets multiplied by 3. So some of you may already see that this is not going to work. I'll show you why, but 3 times 1 would be 3x and 5x. And I can't put signs on that to give me 14. I'll show you what I mean right now. So to get negative 5, one would have to be a positive, one would have to be a negative. So check everything out. 3x times x would give me 3x squared, which works. 5 times negative 1 would give me negative 5, which works for the last one. Now try the outer, which would be negative 3x, and the inner, which would be 5x. That's going to give me 2x in the middle. So what could I do? That's not what I need. I need 14x. So what I could do is I could keep my numbers where they are and just change the signs. But as you know by now, changing the sign is only going to change this sign. So the 3x and x would work. The negative 5 times 1 would work. The outer would give me 3x, and the inner would give me negative 5x. That's going to give me negative 2x, which is exactly what we thought would happen. So what I can do is I can change the position of these numbers. So instead of 5 here and 1 here, I'm going to put 1 here and 5 here. 1 here and 5 here. How does that change things? Well, if you look at this, you have 3x times x, that's going to work. 1 times negative 5, that will work for the last. Now the outer would be negative 15x, and the inner would be x. So that would give me negative 14x, which is not what I need, but it's close. It's just the wrong sign. So what do? I'll change the signs of these. So instead of positive 1, I keep everything in the same position except change the sign. So 3x minus 1 and then x plus 5. So 3x times x is going to work. Negative 1 times 5 will work. Outer would be 15x. Inner would be negative x. And that, of course, is only going to change the sign of that one. So I needed 14x. I got 14x. So this would be the factored answer for number 3 in the notes. Watch the next video for the next examples.